Hi, Sarah. Sorry, I'm running a little bit late. The face-to-face lab ends a little bit late. So, hi. So today we're going to finish the second part of our lab 5. So in first week, we learned the basic of how to import data into R and how to make a how to filter the data, how to make a line graph using ggplot. And basically for today's lab, we're going to learn how to make map in R. So I'll just start sharing my screen. Okay, so basically you just go to your working folder and then you should be able to just go to the folder that you saved your data last time. And it should be under this GEOG 2011 Lab 5 GitHub folder. And here you open the project by double click this GEOG 2011 Lab 5 GitHub. So the file type is our project. So you double click it. Slow. Okay, so now I've successfully opened the project that I saved from last time. So basically last week I demonstrate those the first part of walkthrough, the codes in the first part of the walkthrough. So I should have this line of codes. And also I got those variables that we created from last time. So today we're going to I'm going to demonstrate the second part of the walkthrough. So I'm going to open the walkthrough HTML file. So you can just directly open the walkthrough HTML file from the .html file, or you can just open this R markdown file with file type RMD, and you need that R markdown file again, like what I did last week. But to save time, I will just open the HTML file directly. So you click that, and it will ask you whether you want to open in editor or open in web browser. So I will just open it in web browser. So now I've opened this walkthrough file. So I will put it side by side with my R project so you guys can see it clearly. So basically, here we're going to start with the section mapping with R and SF. So basically, remember in last week, at the beginning of the code, we import 3 different packages: tidyverse, tmap, and SF. So for last week's content, we use a lot of functions in tidyverse, like the read CSV functions is provided in tidyverse, the filter and the pipeline, and also the ggplot. They're all functions provided by tidyverse package. And for today's part, for the mapping, we're going to use mainly use the other 2 packages, tmap and SF. So those 2 packages are packages specified for spatial analysis for spatial data. So first, I'm going to use stRead functions to read a vector layer, the US counties geopackage layer, into our project and save it in the counties object. So to do that, I will just copy and paste this line of code, or you can also type in this line of code in your script. So basically, we're using stRead functions, and here it specifies the file path. So it's under the data folder of our root folder. Here you can see the US counties geopackage file, and string as factors equals to 4. So this is another parameters or argument. You don't have to know deep about it, but just make sure you have it here. And once we have this line code, we just run it. Oops, couldn't find function stRead. That's probably because I didn't. So every time you run your script, make sure you have the package imported. So I will just import those packages again. So run the library line code. Run the library codes again. Okay, so those packages are imported again.
Sorry, how do we do that part? If it said there's an error, there's no stRead.
So run the 3 lines of code. So every time you need to import the
Okay.
root file packages again. So you only have to install those packages once, but every time you're running script again, you need to import them again using the library code. Okay, now I successfully imported them, so I should be able to run this code again. Okay, so after I run the code, it's run successfully. So they're reading layer from this data source, and you can see the geometry type for this layer is multi-polygon. Dimension is 2-dimension XY, and B box is the bounding box. So this specifies the spatial extent of that layer. And CRS stands for Coordinate Reference System. Now it is unknown. And once we run this data, we have this counties spatial object, and you can also find it under the environment tab and the data here. So you can click this object and see it has all the attributes. It's like a attribute table of a layer in QGIS. So we have this GIS join county variable, we have total population variable, we have FIPS variable, and we have state FIPS variable. And also they have another column is GOM. It stores the spatial information of this spatial object. So now I can close this again. So now we successfully read this data. And basically, this is how we read spatial data. And next, once we read the spatial data, we have this spatial object. We can make a map. And to make map, we're using functions in tmap package. And the code to make map is tm shape. Here in tm shape functions, you specify the data you're going to map. So we're going to put the spatial object counties. And then we use plus sign to concatenate other functions in tmap. So here we're going to use tm polygon. So now these two, we can make a map using these two lines of basic codes. So basically, tm shape counties specify the spatial data you're going to map, and the tmap polygons tell the programs that map it by county. Show it as map it by polygons. Show it as polygons. So now we can run these two line of codes. Once you finish running the codes on the plots tab, you should be able to see this basic map in grayscale, right? So any questions so far? Any issues so far?
No.
Okay, great.
I don't think my file's saved from last time, so I might just have to step out of lab and like follow this along later because I think I have to redo the last thing.
Okay, sure. If you want
Yeah.
to stay out, that's fine. Or you can just follow what we do, or you can also check out the Zoom recording later. We will have a Zoom recording for this. That's fine.
Sorry.
That's okay. Okay. So now we've made this basic map. Actually, remember in QGIS and ArcGIS Online, we make more fancy looking map like choroplast map, so we can map specific variables and using specific classification schemes. So actually, we can also do that using the TMap packages here. So remember, so we can modify these codes and to make better looking map. So remember when we make choroplast map, first you need to specify a variable that you are going to plot, a numeric variable, right? So here, remember in this county spatial object, we have one numeric variable, which is the total population, right? So we can make a choroplast map of total population by county. So to specify the variable you are going to use, you put the variable in the TM polygons functions in the parentheses, type in quotes. So the variable should be wrapped in quotes. And the variable name is let me check. It's total pop. So yeah, you can just type in here, total pop. And then you can run the codes. Again, these 2 lines of code. So once we finish running, we see we have a choroplast map, even though it doesn't look good. So, but at least it is a choroplast map. So we are the variable we're mapping is total population. You can see it in the legend. But by default, if you don't specify the classification scheme, by default they're using equal interval. You can tell from the legend that they're using equal intervals, right? So and the total population data is skewed, so that's why it doesn't look good on the map. But don't worry, later we will show you how you can change your classification scheme. But here we can further modify this map, these codes to add a title to this map. So we're using TM layout functions, and here you just type in main.title equals to, and here you put the title you want to put in here. So here we can put the title of total county population here. So now we can run the 3 lines of code again. And now you see our map has a title now, right? So that's because we're using TM layout. And next, we're going to change the classification scheme of this map. As I said, the data is skewed. Equal interval obviously doesn't look good on this map. So here we were going to change the classification of this map to quantile. So here to do that, you will use this style equals to parameters. So it's also in the TM polygons. So you just type in comma and then style equals to. And here we're using quantile. And then we run the codes again. And now we have this better looking map with quantile classification scheme. It's more visual balanced. right? So that's how you specify classification scheme. And here I also want to mention that, so here you specify your classification scheme using this style equals 2, but this programming language is dumb. So it only takes specific values for that style parameters. So here what you can do is that go to help tab. So help tab, you can in the search box, you can search the search by function name, and then you know how to use each argument or how to use each parameter. So here we will just type in TM polygons here. If you have questions for other functions, you can do the same. So once you type TM polygons, you hit enter. And then in the result, it shows the TM field functions under TMap packages. Don't worry, it's not that, even though it's TM field, it's not TM polygons, but these two functions share similar arguments. So that's why they show this result for you. And then you can scroll down under arguments. You can find they take lots of arguments, lots of parameters, and here you just go to style. So we're using this style equals to specify classification scheme. You can see that it's the method to process the color scale when COL is a numeric variable. So it takes different values. So like cat, I think it stands for category, fixed, SD I think stands for standard deviation, equal interval, pretty, quantile, k-mean. So it shows you a list of values it takes for that specific argument. So here we're using the let me see, the quantile one. So that's about that argument. And yep, and so now we have that fancy looking county map of total map of county total county population, but that's using the county spatial object. Here we want to go back to our mobility data we used last week. So we want to make some map based on the mobility data we have. So first we want to further filter our original mobility county data to have the mobility object we want. So here basically we only want the data for state North Carolina, and for the place type we only want workplaces, and for the date we only want April 2nd. So you can just copy this line of code here, and this part is already you should be familiar with it because we've covered it last week. And here we just run these 4 lines of code. Once you run the code, you should be able to have the object here in the environment tab. So now we have the data we want, but this data is still in tabular format. It doesn't remember we import the mobility county from a CSV file, so it doesn't have any spatial features in it. So how we are gonna make a map from this data? Remember in QGIS, if we want to map some CSV data, we join that CSV table or data to a spatial layer, and then we make a map. So here, similar in R, we're going to join this mobility NC workplaces counties data to the counties layer we have. So to do so, we were using the pipes and inner join functions. So I'll just copy the code here. So basically, we're creating this new spatial object called counties NC mobility workplaces 0402 SF by inner join the spatial object counties and the mobility data we just created. So it's similar to join in QGIS. That's how we do join. But remember, in QGIS, we need to specify the variable of the two data you want to join. So here you didn't see any codes that specify the variable we use to join. That's because by default, if you don't specify the variable you're used to join these two data, they were using the common variables. So they were using a variable that shared variable between the two data. So you can see that in counties object, we have this FIPS variable. That's, I think, county FIPS. Yeah, that's county FIPS variable. And also in this new mobility object that we created, we also have FIPS variable. So they're joining these two data by the FIPS variable. Okay, so let's run these two lines of code again. And you can see in the console, they're joining by the FIPS. Right? So now we have this new spatial object here, counties NC mobility. So if you click it, open it, you see it has all the attributes from the two data, and it's a spatial object because it has this GEOM attribute. Okay, now we have our spatial object ready, so we can go ahead and make the map using the TM shape and TM polygons. So here, let's just copy the code here. So it's similar to previous codes, how to make the map for the US counties layer. So here in the TM shape, you specify the data you use. And also you can specify the style is Jenks classification. Actually, this can also goes into TM polygons functions. So we are mapping this spatial object, and we show it as polygons. And here we are using this, we are mapping this percent difference variable. So mobility percent difference variable. And then we're using Jenks classification. So you run it. So once it finished running, you should be able to see this North Carolina map and Coroplast map. The variable is percent mobility difference, right? So yeah, this is how so now we make a map based on the mobility data. So until now, all the maps we made is static map. Actually, using tmap variable, we can also create an interactive map like this. So we have these tmap mode functions. Basically, these functions takes two values. One is view, and the other is plot. So by default, it's the option. By default, it's plot. So that's why all the maps we made are static. So plot is for static map. But if you want to change your map to interactive options, you can just run. You can just run this code. So in view options, so after you run it, after you run it, you can see in the console tmap mode set to interactive viewing. So all the codes you run after it, they will be interactive. So now we run this TM shape codes again. You can see the result is in the viewer tab and it is interactive. because we have a base map, so usually we will set the transparency to semi-transparent. So here you just type in the TM polygons. You can just type in comma. We use alpha to specify the transparency. 0 means total transparent. 1 means totally not transparent. So you can set something like 0.7, so it's 70%. And you run the code again. So now it's more transparent. And here you can see in the interactive, you can zoom in, zoom out. We have the legend. If you click the each polygon, we have pop-ups. And if you hover around different polygons, they will show this little tag. Actually, if you're interested in it, you can further look the TM polygons in the help. And you can actually change what you want to show here in the pop-ups. What do you want to show here in the hover? But that's a lot, so I will not go through it here. And also here, we have this button, looks like stacking layers. And if you hover over there, you can change the different base map options. By default, they're using S3 word grid canvas. You can also change it to OpenStreetMap or S3 word topo map. So here you can change the base map. So that's for the interactive mode. So if you want to change back to the normal mode, you just the normal static mode, you just type in tmap mode plot, and you run it. Then you can see in the console tmap mode is set to plotting. And then if you run other code after that, it will go back to static mode. See. So any questions so far?
No, thank you.
Okay, great. So basically that's all we need. All the basic functions you need to know for the second part of lab 5. Basically, so after you go through those two here of the walkthrough, you should be able to finish the rest of your lab 5 script, starting from line 37, I believe. Yeah. So from line so for after last week's lab, you should be able to finish from line 1 to line 37, and after today's lab, you should be able to finish the rest. So here, basically, you need to start from line 37, you need to create 2 objects with mobility data of workplace type in Georgia on March 12th and April 16th. So we have the code here. You need to replace the blanks here with your own code. So basically for these 2 blanks, you need to fill in the date you want to filter for these 2 data sets. And next, you need to read in the county boundary file, the US counties geo package, fill in the name of the right function to do so. So here the blank is in the function name. So here you need to know what function you use to read the spatial object. It's similar, it's same in the walkthrough. And then you need to join the 2 mobility data to the county boundaries. So the blanks is here. So you need to know what we put in the inner join. And here, last part, you need to create 2 maps using tmap similar to figure 9. Actually, it's not figure 9, it's figure 7. So yeah, it's figure 7 in the walkthrough. So here to make the map, make sure you're using the percent difference variable for your choroplast map. And for the classification scheme, you need to use the fixed classification scheme. Remember in the help, the style argument takes a bunch of classification scheme. So you're using this fixed classification scheme. I will explain it later. And the intervals should be the same for both maps, so because you're making 2 maps for 2 different dates. Also add a title called Mobility Change of Workplaces in Georgia, March 12th, and Mobility Change of Workplaces in Georgia, April 16th. So basically, you need to here replace the blanks here, what the data you're going to map, what variable you're going to map, and the classification scheme here. And here you need to replace the blanks with the title you want to put in here. And you're making 2 different maps for 2 different dates. So basically, that's what you need to do for Lab 5 script. But we also offer 2 extra credits. So for 1 point extra credit, you need to create interactive versions of the 2 maps you made from these lines of code. So similar to work through this, to the walkthrough map of this. Where is the map? Oh, it's here. But here, make sure your map, your layer is semi-transparent. So you need to set the alpha value. Also, using a different base map. Here, we want you to use the OpenStreet base map. So you just change it here. And when you submit that for extra credits, you can just take a screenshot. And for 1 more point extra credit, we want you to create a small multiple map of Georgia for 1 of the 2 dates used in the lab. So you can choose either, remember when we creating the map, we create 2 dates, March 12th and April 16th. So you can choose either date and create a small multiple maps showing workplaces, residential and parks places on mobility change. And here I will talk about that part.
I had a question for part 1 of the lab also.
Okay. What's the question?
In like the first part, it said, I think like in line 27, it was talking about like the title to give the map, or it said like give the plot main title, and then like it had that listed, and then in the next line it said give a title percentage mobility change. So I wasn't sure like which title we're supposed to use, or if I'm like, missing something.
So in the first part, you're going to make a line graph.
Mm-hmm.
So the title for the line graph should be percent mobility change of workplaces area by date in Georgia.
Okay.
And for today's part, for the second part of this lab, you are going to create 2 maps, and this is the title for the maps.
Okay. Is there? Yeah, but it says like give the plot a main title of line graph of mobility change smooth in Georgia. So am I supposed to also put that somewhere, or just?
Oh, sorry. You mean?
Yeah, like from on line 27.
Oh, okay. Sorry, because this is a modified version of the so you don't just ignore that.
Okay, I was just confused. So I was like, it said 2 different titles, so I wasn't sure if there was like something else we were supposed to
just
make.
ignore line. So ignore the smooth part. So we delete that smooth function in this version of tutorial after give the plot a map. Just ignore this part. So give the x-axis a date variable, a date for the x-axis, and percent mobility change for y-axis.
Yeah.
And make the line red, and the main title should be this.
Okay. All right. Thank you.
So yeah, thank you so much for pointing that out.
No problem. I just thought I missed something. I was like, because I've never like.
Because when we're just changing the version of this map, so we didn't notice that. Okay. Next part, I will go through this, going further with mapping part. So actually this part is not really required, so it's more advanced. But here I will talk about the fixed classification scheme. So just be careful about that part, and you can just follow for the other part, for the small multiple maps, it's just for extra credits, so it's not really required. So basically here for this part, we're going to make a small multiple maps for North Carolina in actually not March 12th, just for April 2nd, and in three different places types. So the mobility change in parks, the mobility change in residential place type, and the mobility change in workplace type. So to do so, first, we were going to create that mobility object, right? So we're using these codes to filter the mobility data. Following the walkthrough. So in this code, we are filtering for just North Carolina state. And instead of filter for just one type of places, here we want to filter for three types of places. So remember, in previous codes, we use types equals to workplaces. Here we use this percent in percent to make the condition. And here we use a little c with parentheses to wrap these three values. So basically, if a row in this mobility county, the state is equal to North Carolina, and the type value is equal to any of these three, and the date is equals to 2020 April 2nd. It meets the criteria we want for the filter. So we will just run the 4 lines of codes and then creating this new variable called mobility NC counties. Any questions so far?
No, thanks.
Okay. And then after we filter for the mobility data, we're going to do the join. So it's similar to previous codes. So we join this new mobility data with the county's spatial object. So just run. Then we got this new spatial object here. And then we can make a map based on it. So tmap mode change. So basically for the small multiple maps, it looks best in a static version. So you need to change the tmap mode to plot, but we already did that. So we don't need to do it again. And then this is the line of code, the lines of codes to create the small multiple maps. So I will just copy it here and run it and then explain it later. So here you can see this is the result of the map. Actually, sorry, there's something wrong in the title because the data is just filtered for April 2nd. So it's not March 12th and April 2nd. It's just April 2nd. Sorry about that. I will run it again. Okay, now it's the correct map. So here I will explain the codes line by line. So TM shape, it's easy. So here you specify the data you use to create the map. TM polygons, you specify the variable percent difference. And here we have a title percent difference here. So this title is different from the main title we used in TM layout. This title is the title for the legend. So see in the legend, we have this percent difference legend title. And here, the part you need to know is that we use this fixed style classifications scheme. So basically fixed style is like, it's similar to manual breaks in the ArcGIS Online map. Do you remember in our ArcGIS Online map, we manually input the breaks. So here, if you're using fixed style, then you can manually specify the breaks here. So just this plot is bigger. So you can see we have these breaks equals to argument, and you just put in all the breaks in this C parentheses. So you have this this represents a list of values. So this C and parentheses represent a list of values, and here is the your value breaks. So the minimum is -61, and the maximum is positive 66, and here you have all the breaks in between. So this is aligned with what you have in the legend, right? And remember, one thing you need to remember that here you need to specify the breaks by yourself, and it's important that the minimum and maximum is aligned with your data. So here we are mapping the percent difference variable of our this counties NC mobility data. So if you take a look of that data in the percent difference variable, if you just open that data in the percent difference variable, you can click the variable name to sort the data. If you click once, it will sort the data ascending. So in the ascending order, so you see the lowest value, the minimum value is -61, right? And then if you click it again, it will sort the data descending. So now you know the maximum value is 49. So actually here it should be 49, not 66. And so by looking at the data, you know the minimum and maximum value. And that should be your lower bound and upper bound for the breaks. And then you can determine the breaks in between. So if you want more breaks, you just put more values in between. If you want less breaks, you just put less value in between. Okay. So that's for the fixed style classification. And then alpha, we already explained that. That stands for transparency. So 0.5 means it's semi-transparent. And palette, this is for color scheme. They specify the color scheme. And here the color scheme we use is reversed red, yellow, blue. So it means the color scheme is actually blue, yellow, red. So the lowest value, the lower value would be blue, and the higher end value would be red, and the value in between would be yellow. So this is already showing here. And here, this is not required. But here, if you are making your map for your own research, here where you the values they take for the palette argument is from the color brewer palette. So if you just search color brewer, you can just click here, our color brewers palette. You can see they offer a range of different how do I say, color scheme, and they have a name for each color scheme. For example, like this yellow, orange, red, yellow, orange, blue, brown. Well, each anyway, each color scheme they have a name, and you can take those names to here to specify the palette if you want to make more pretty looking map. And if you here, so for example, this one is yellow, orange, red, and if you want a reverse version of that plate, red, orange, yellow, you can just add a negative sign here, like here. And pop-up variables, it's not really necessary here in the static map. It's for interactive map, so you can just ignore that part. And then the TM layout, basically the TM layout, you specify the main title, the whether the legend outside, whether the legend should be outside of the map or inside the map, panel label size, legend title size, legend text size. So all these different parameters, it's similar to like you use print composer. Remember, you can play around with the layout in the item properties. So this is similar to that. And to know what arguments you can put here and what values it takes, you can just further explore it here in the help. So you can search TM layout and see what you can put here in TM layout. So see what legend, what arguments it takes. So, and that's TM layout, and then TM facets. So this is the function that actually make these small multiple maps possible. So here, using by equals to variable, or this argument. So you're meaning you're creating a small multiple maps by place type. So this is the variable for place type, right? So we're remember when we filter the data have 3 different place types: the parks, residential, and workplace. So they will make a small multiple map by this variable. And here are some other variable you can. There are some other parameters or arguments you can further. Similar here, you can further explore them. What does that mean in the help document? And then the last is the TM credits function. So we use this to clarify the credits, the data source. So see here, it's bigger in here. We have data source for each small multiple maps. So here, this is the place that you specify them. And you can also specify specify the position that you want to put the data source. So here in this case, it's put they're placed in the bottom left part, and you can specify the size. Similar, you can. So there are a lot of things you can play around with tmap and those functions. So if you want to know more about them, just type in the function name in the help, and then you should be able to know. So basically, that's the part for the extra credit. And any questions? Okay, so then just fill in the just finish the lab 5 script, and also here actually I want to mention that in the lab 5 tutorial here. We have, so basically for lab 5, so what's, yeah, 2 main things you need to do: create a line graph and create 2 maps in Georgia that show the percent mobility change of workplace by county on March 12th and April 16th. So once you finish the lab 5 script, you would have those results. And there's also extra credits. So I already explained that. Also submitting your assignment. So make sure you create a Word document that includes the screenshot of the line graph. So not smooth percent. The percent mobility change in Georgia by date. Screenshot of the exported map, the 2 maps, the maps of the 2 different dates. And this is the requirement. And also these 2 optional is for the extra credits. Yeah. Yeah. Sorry. Maybe the script is wrong. This is 2. So the interactive, you got 1 point extra credit, and for the small multiple plus, you got 2 extra credit. And here you also need to answering the questions in the and include that in the lab document. And also lastly, remember to submit your finished lab 5 script with a Word document. So you do not need to include the lab 5 script. You do not need to copy and paste that into the Word document. Just when you submit them in the assignment Dropbox in ELC, you just submit this file, lab 5 script. It's a R file, and that's all. Yeah, that's all we need for lab 5. And this would be our last lab. Any question?
No, thank you for your help.
Great. So if you don't have any questions, you're free to go.
Bye. Thank you. You've
Bye.
been great all semester. I haven't come to the Zooms a lot, but I've been watching the videos mostly. But you're very helpful.
Thank you.
Okay, bye.